So what is Charm? You're soon going to hear more about it, but it's a basic company whose mission is to remove carbon dioxide from the atmosphere permanently. And it's also a part, I would say, of a sort of new type of industrial companies that we're starting to see in San Francisco. They're both founded and based here, and I know you have your headquarters and factory down a little bit south of here. And as a long-time San Francisco resident, I'm just super excited and proud of that, so thank you very much for that. But without much further ado, welcome Kelly and Sean. So, you're removing carbon dioxide permanently from the atmosphere. Tell us, how do you do that?
Charm's process takes agricultural waste, so things that are left over after the harvest of corn and wheat, so namely corn stover, wheat straw. We've also fed in almond shells and walnut shells and a couple other
forestry residue.
Yeah, test products like that into our giant machine, which is a rumbling shipping container, which converts it from that biomass that we grind down into sawdust effectively and inject into the reactors. And then in a short period of time, it converts it into an oil. And we take that oil and we transport it to an injection well where we pump it underground as a carbon removal technology. And then the long tail of what Charm works on is green steel production, but we can touch on that later perhaps.
Oh, thank you. You literally were building things for space. You were in space, building rockets, satellites. So what prompted the move to sort of, no pun intended, come down to Earth and start doing this many years ago?
Yeah, I think Peter had reached out to us with our other co-founder at the time, Kevin, and one of the things that Sean and I think excelled at, or got to know a lot about in the process of building satellites and small rockets, was how to take these large slow-moving industries and innovate within them. So that's using off-the-shelf components, taking kind of an agile approach to hardware development, and building small modular systems. And so when we had the opportunity to work on what is the greatest problem of our time, like climate, we could use those skill sets of building small modular hardware systems to kind of rethink chemical plants generally. So how can we take biomass and turn it into something that can be used for carbon removal, but do so in a way that allows us to move more quickly and solve a lot of the problems that we currently see today in the chemical industry.
Mm-hmm. And even before we jumped into climate, we had a circle of friends who were passing around spreadsheets being like, what can we do? How can we help to impact this massive problem that we're facing? And I think that's probably how a lot of your project started as well. Spreadsheets kicked around between friends saying is this a business?
Yeah, and when we were at Planet, the mission of the company for these small satellites was to image the entire Earth every day and do good with it. And so when we were designing satellites, we wanted to see the Earth change on human timescales, so daily, as opposed to what the current satellite data sets were, which were on the order of could be years, but sometimes months at times. And so now they're even getting into some things like carbon mapping and so on. But that mission was very resonated with me when I started to join startups within the Bay Area. And so I think the mission motivation aspect of starting a company and doing so with the intent to do good and to help the planet was really strong.
Amazing segue to my next question. Actually, why did you decide to found a company yourself, rather than just taking a job? I mean, or what was the thinking there, or what motivated you to do it?
I think 4 years ago there wasn't much. We started a company that was working on trying to find a solution in this space. The mission of Charm is to reduce global CO2 levels. So we're a technology agnostic organization, and we're trying to find a solution to this in a hardware space. And I think that when we were interested in moving into the space a few years ago, there just wasn't a breadth of organizations to apply our skills to. And actually, we weren't even particularly looking to move into climate. It was more something that came in side channel, and they were just like, you should be doing this. And it's like, well, yeah, of course. So here we are.
Right, as a mechanical engineer, I was not even aware that I could use those skill sets in the chemical industry. I have friends who are in chemical engineering, and they often feel this pull at the end of their university time there where they're like, do I have to go into oil and gas? It seems like the only pathway for some chemical engineers. And so as a mechanical engineer, yeah, I didn't know that I could work in climate until we really started this and found out how many mechanical problems there are, how much chemical engineering can be involved in this sort of space.
Thank you. So you started Charm in 2017, if I understood correctly.
I think it was 2018.
Yeah,
Around the
sort
time.
of vague.
Right.
Yeah.
I guess that's always like when exact was something
Yeah.
started.
We opened the first store in 2018, but yeah.
Yeah.
And if I sort of understood it correctly, the current approach that you sort of very accurately described was something you really doubled down on in 2020. Like, talk to us like from when you decide to start this, you have your mission and you sort of stumble almost a little bit into it and arriving to that like solution where you feel like this is worth doubling down on. Like there's a couple of years there. Like what was that like? What took us through it? What happened?
It was disheartening, I guess, initially. No, I think we were initially working on biomass to hydrogen. And biomass is light and fluffy, and hydrogen is light and fluffy. Biomass is difficult to transport because of that fact. Hydrogen is difficult to transport because of a number of historical challenges with transporting hydrogen. But in trying to close that economic model, the only point in building a prototype is to check your assumptions. And so we built a few versions of the pilot plant, and then we started to realize, like, this really doesn't close at scale. We can't bring in massive, like millions of tons of biomass into a site to convert it to hydrogen. We can't truck tons and tons of hydrogen around the US. And so it started to show the cracks in the foundation of what we thought was our business model. And I think at that time, we sort of went back to our investors and we're like, look, this doesn't close. Like we had an assumption here that was incorrect. We had an assumption here that was incorrect. We had a document called Charm's Likelihood of Success initially, which one of our investors just pointed out again. And it was a document where we had each risk called out and how likely we thought it was that we'd be able to address that risk. And they were things that we had called out initially. It was like transport economics, and it didn't close. And so I think we had to take a step back at that time and say, well, what can we do to actually either close this business model or close this business? And so we had the breakthrough to split the machine into two. And so we take the biomass and we turn it into oil, which gives us about a 10x densification on the material, which then leads to mass limited transport versus volume limited transport. So we have that ability to transport it over long distances. And then the second half of our machine takes that bio-oil and then upgrades it into syngas. And then initially we were considering going all the way to hydrogen, but once again, like digging into the economics, you find out that to get to the 5.9 purity hydrogen you need for most end-use applications, you have to remove a ton of material out of your gas stream, and so the economics don't close there either. And so we had to find sort of different market fits within that, and that led to the breakthrough for underground injection of the bio-oil, like addressing the bio-oil as a material that had value in its carbon content as opposed to its energy content, which people have been pursuing for 30 years, trying to figure out how to use bio-oil as a fuel, but it has a lot of oxygen and a lot of water, which makes it not valuable as a fuel, but instead valuable as a carbon-containing fluid. So, and then finding market demand for that. So we created a shape of what we thought a company would look like, and then we sold out through 2024, which I guess is what Peter refers to as product market fit, which was pretty exciting.
So, and maybe it's fascinating, the name of the document. The next question is really around actually like how do you validate idea, how you like know you're on the right track. Can you maybe just elaborate a little bit on that document? And go, like, that's fascinating. Like,
yeah,
did you start with that document and then like, or yes. Was that something you realized over time that you needed?
No, I think it started like more or less at the same time as the start of the company, because what you're trying to do at a startup is like you have a giant list of assumptions. You're going into a space that is, if you're starting a company and you have a fully formed idea and a product market fit, like then I guess you don't need the spreadsheet. But for us, like we were in a discovery phase, and so we were trying to measure what is each thing that we need to verify in terms of a prototype or in anything else. So we use that as like a foundation to see what we should be building, what we should be testing.
And in terms of the bio-oil sequestration, Shaun's breakthrough really happened, it was like March 2020. We were locked down in our apartment, and as hardware engineers, that's really difficult because we're used to building things. And so we were kind of starting to go back to like the to-do list that we would get to eventually, which was, we have some of this bio oil, and how do we get rid of it? We could eventually upgrade it to syngas, but what if we had extra? What if that quality of that bio oil wasn't good enough to upgrade it to syngas and put it into our nozzle, which has certain requirements on it? And so Shaun started going down the rabbit hole of being like, how do I dispose of this? And part of that was learning about underground injection in the US, which is how a lot of liquids are handled, and they're actually injected underground. And then realizing that we have a liquid that's full of carbon, and does that count as carbon removal? And starting to poke around with industry experts, we found that there was kind of this new, not industry, but like new angle of carbon removal that was being discovered or like generated, which is biomass carbon removal and with carbon sequestration, which is similar to bioenergy with carbon capture and sequestration. And a lot of the people in there were thinking about biomass and how you can consider it for carbon removal, like biochar and things of that nature. And so we started talking to them and geologists and underground injection experts to validate whether or not it was even possible from a just pure industry perspective, industry and science and physics perspective. And everything started to check out, which is then when we went to Stripe and said, hey, we have this new carbon removal technology. What is it? How does it sound to you? And that quickly took off to Microsoft and Shopify, et cetera.
And maybe just linger still a little bit more around the spreadsheet, maybe like, so you know, from the outside looking at what you do, it sounds like this almost like insanely long funnel of like it starts in the fields of Iowa with corn, right, and ends up at this, you know, oil well thousands of feet down and there's all of these conversions that needs to happen, and I'm sure like friction and you basically need to innovate in every single field. Like how, unless maybe you have unlimited resources and time and employees, which I guess you don't, but how do you decide what to even start attacking in this funnel? Because I guess it's 1,000 different things you could be working on. What does your product development process look like, I guess?
Yeah.
Presentation.
Do you want to talk to it? This is the, or I can, either way.
Oh, like our product development process in terms of the pyrolyzers that we're developing?
Or really anything. Like what do you decide what to even work on? Like to where to devote your resources to?
Sure, yeah. I think, like Shaun was mentioning with all of our assumptions, in the product development or hardware development cycle, you do have a set of assumptions that you're basing off of. The same way that you would have to evaluate from your business, okay, like do the transport economics check out, do all these check out. In your hardware development cycle, you also have to do those things. And so one of the first things that we decided to do was really go and do the deployment first. So build a pyrolyzer that could make oil and get it to the field as fast as possible to make sure that we have checked all of those assumptions and we didn't miss anything, run into all of the possible walls that we could run into, so that we knew when we refined the design the second time that we could take into account all of those different constraints that maybe we didn't initially anticipate. One of those was winter. So like as we design here in San Francisco, it can be very simple. We knew that when we went to Kansas with our pyrolyzers for the first time that we would encounter cold temperatures. But there's something very different from just saying like, does this material survive at low temperatures, to saying, can I operate my air compressor at low temperatures? If I operate it at low temperatures, does the dryer work? If the dryer doesn't work, you have water in the lines, you have ice in the lines, you no longer have an air compressor. So there's this cascading effects that we're doing. And so all of those assumptions then get baked into the next model, and then we look at what are those hardest challenges, what are those challenges that we need to tackle right now in order to reduce risk later on, and where do we need to devote like most of our engineering development. Right now, after going to Kansas and figuring out all of the different roadblocks and things and hurdles we'll have to encounter, we now want to focus on the reliability and the rigor of the machine. And this is so that we can start really testing like A to B studies on the machine. So if we have a rigorous like first model, we can start saying, okay, we're going to build a new reactor. Does this improve our yield or optimize our yield here? We are starting with a solid baseline and can test against it. One thing that the space industry has done really well is when you think about the constraints of a satellite or a rocket, which is our background, you say, okay, it's going to encounter a ton of launch loads. And when it goes to space, it's going to be in vacuum and it's going to be extremely cold unless the sun's on it, right? And they've had decades spent basically testing the assumptions of, will this thing survive in space by saying, oh, I have a thermal vacuum chamber, or I have a vibration table and a shock table to like just put my design on. From the chemical engineering perspective, you can't really test your designs easily. You have to have an all-up system that says, okay, we have this biomass, and now the biomass needs to get to this particle size. And then when you put it into your process, you need to then be able to, you don't have simulated gas streams or simulated streams of your biomass to test upon. So we're working on developing the integrated rigorous system to be able to test all of future designs on and challenge those assumptions.
Yeah, it's basically the same thing in like the software development world where you have a unit test baked around a piece of code. We need that same unit testing around each piece of our subsystem, but generating those simulated streams within the process is extremely difficult without doing it as an all-up machine. And so partially what we're looking at is like, how can we branch off at different parts within our process and actually feed that into a system under test? But unit testing is, as you all know, a challenge. So.
And then at a macro level, I think we have making the oil, and then we have putting it underground, and then we have making iron, which is kind of the long tail of charm. And so we want to be able to test all of those at the same time, right? So we have our operations team who's really focused on testing and the assumptions with the sequestration. What kind of impacts does it have? How difficult is it to put bio-oil underground? Then we have us who are testing the assumptions about making oil. How hard is it to make this piece of machinery? How can we make it work at scale, et cetera? And then making iron, we have another pilot plant development process. So one of the ways that we've been able to move so quickly from like the company perspective is being able to test sequestration using bio-oil that has been developed by other companies. So we can actually put oil underground today and test all of those sequestration methods without having to constantly be blocked by a hardware development process of a fit-for-purpose machine that could take a lot of different, like there could be a lot of hurdles, there could be a lot of roadblocks in the way. So we're trying to spread the load of testing those assumptions across the company from our operations team to our engineering team.
Yeah, and so when we look at our list of the probability of success at Charm, whatever has like the highest risk, we think what are the parallel paths we can do to reduce that risk. Yeah. And I think the initial likelihood of success was like less than 1 in a billion for when you took all of those risks that we had and like the percentage likelihood that we had to succeed and multiplied them out. And then we brought that to our seed investors and said, "What do you think?" And they said, "Sure, here you go. Like, good luck." You know. So it was, and I mean, I think the nice thing about working in the climate space is there are people who are interested in those, 1 in a billion shots. And I think Charm has moved up in that risk ranking, but we are still, it's still not a guaranteed success.
And maybe there's a question from a person who sent in earlier, but I'll fold in here. Basically, the question is like I'll quote: "You seem very vertically integrated today. How do you think about yourself or the industry or CDR industry at large? Like, is that the path forward for the next decades or so? Will we have these vertically integrated solutions, or will you see a path where we move towards more like a platform or like things moving, like building into each other, or?"
Yeah, I think to be able to hit the price point that we need to hit with CDR, you don't actually have the budget within that for middlemen to operate in that space lucratively. So the long tail of Charm is talking about like how do we reduce the cost of biomass on the field through fertilizer, basically by the biochar being used as a fertilizer. And so we're talking about like how do we reduce by pennies at the long tail of our process? And that really means you have to keep all of these things vertically integrated. And so there's questions of like what we can do in the long tail to get either operators incentivized to operate the equipment as more of a commercial deployment at a larger scale. But like I think the price point really makes it difficult to try to find those those operations that you can carve off, because there's no profit in carbon removal. Like everyone is trying to operate like at the delivery price point. And that's because every dollar that you like carve out of that is carbon that's not being removed. And so that's I think one of the biggest challenges with scale, and why you may see so much vertical integration in these spaces.
Right. I see. So actually, let's talk a little bit about prices here. And I was like personally, like, you know, I'm from Sweden originally, and I probably fly there more than I should admit I do. And I was like, wow, amazing! Now I can offset my trip, and the calculation realized that's like the equivalent of right now. I believe the cost is $600 per ton. That's roughly one round trip to Sweden. Oh no, sorry, one single trip to Sweden, and all of a sudden became very expensive. I realized. But the great news is so that you at least have at one point said that you think you'll be able to go as low as $45 per ton, and then all of a sudden we're talking, right? How? I guess first question we can is just what are like the major like high level what needs to happen to get that more than 10x reduction in price? Like what are the big breakthroughs, or is there a million breakthroughs? How does the path to 45 look like?
Yeah, I would say that some of the initial breakthroughs are producing pyrolyzers at scale. So being able to reduce the capex of the pyrolyzer by building it more in like a factory type setting, like a car, or a piece of farm equipment. The second one is making it much more automated. Chemical plants are traditionally very manual. There's always like two people sitting at a control room, two people kind of walking the grounds, one person in a lab. Like you need to be able to use software and automate those processes and not necessarily need someone at the helm of it all the time. And we think that that's possible. We've seen it done in satellites and now for chemical plants. So the third one is biomass. Shaun mentioned it a little bit before. So the cost of biomass in a bale form is about, let's say, $60 to $120 per ton. That makes it hard to get to 45, right? But a lot of that cost, what we found, is in the baling process. It requires somebody to run the baler and spend time on the field doing that, and then rent the equipment or use the equipment that they have, and that costs some money. So what we want our pyrolyzers to look like at scale is something that actually goes on the field itself. So that's something that looks like a combine harvester, tractor type format, and then that does the biomass processing using traditional farm equipment types of machinery, and then injects it directly into our pyrolyzer and makes that oil on board. And so that can drop the biomass cost to much lower than the $45 per ton. So those are kind of the big three areas that we're focused on, at least on the hardware side.
And on the actual like storage side, is there
that's really minimal.
That's solved. All right.
Yeah, I think we have challenges to address in every aspect of the charm business, but I think injection is definitely something that is surprisingly cost competitive. And in terms of like the overall cost of a ton, very little of it is in injection and well cost. And
I think that's a key breakthrough, right? Like putting a liquid carbon underground compared to putting CO2 in a gas, like you don't have compression costs, you don't have those energy costs of getting it, pumping it underground. Liquid is much easier to pump, and so
and transport.
And transport,
And it's obviously, you know, nascent market is early, price point today $600. In terms of what you're seeing from your customers, like if you were to speculate, what about the elasticity of demand? Like if we get from 600 to 500, things will happen. Like how do you see demand going forward as prices, you know, hopefully start dropping? Like will there be certain inflection points, or is it going to be pretty linear, or what are we seeing in the market?
Yeah, the way we see it is that the total contract value for voluntary removals is somewhere on the order of like 100 million, or that was our initial estimate for the total market size. Obviously, with things like Frontier and these other advanced market commitments, there's been additional movement in that space, so it potentially is a larger market, but we don't see it as extending for more than a few years. That is something we can depend on at a $600 per ton price point. Beyond that, you get into the non-voluntary markets, so the regulated carbon removal markets, be it LCFS, 45Q. There's other states that are opening their own like kind of cap and trade adjacent standards for carbon removal. That space, I think, is likely about a $1.5 billion market. So once you can sell at the $200 or so price point, the US has a $1.5 billion market you can sell into. And so that's a huge amount of capacity available for sales. But then, and there's other like nation states coming into this as looking to procure negative emissions. So I see that market expanding, but it's not something that Charm is relying on for more than the next 10 or 15 years. And that's where we get into our steel production. So a lot of what we work on right now is in ramping the production of bio oil. But then the long term, we're working on the reduction of iron ore. And that process is currently 6 to 8% of global emissions. But using the technology that Charm's developing, we can turn it into a carbon negative process. And so that is selling both two commodities out of one site, being carbon removal and steel. And so you can modulate the price of those two based on market demands.
And is that path forward, potential path forward, the steel path, let's call it, is that as a hedge, almost reaction to basically voluntary or involuntary or markets not growing as fast as you would like, or what's the rationale behind that? Or is it just that like carbon removed per dollar spent from you is just so much higher, or what the...
It creates a second value chain for the carbon removal, and so it hedges the risk on the market demand side. I mean, ideally, if the markets grow at like an alarming rate and Charm can start producing more and more pyrolyzers for carbon removal solely, that's great, but it doesn't help to decarbonize a hard to abate industry, be it steel production. So no matter how much carbon removal Charm is doing, if steel producers are still at 6 to 8% of global emissions, there's a huge potential unlock there for further reductions. So you get an avoidance by using our process to not produce the fossil fuel derived steel, and then you also get the carbon capture. So it sort of opens up a larger value proposition for our business, but it's also an $800 billion plus annual market. So usually when you're starting a company, you want to kind of target those bigger markets. So
I heard that's popular.
Yeah.
And the bio, I think for every biomass ton, you get like a 2 to 3x impact by using it for making metallic iron in a carbon negative way versus putting it directly underground via bio oil sequestration.
Thank you. I have plenty more questions, but I definitely want to open this up to the audience here. So, thank you very much. Who wants to go first? Not everyone at once.
I have a question based on what you just said.
Yeah.
You were talking about the difference in yield. Sorry. Yeah, of course. You were talking about the difference in yield between injecting the bio oil versus using it for reduction of iron ore. Why is it that it's 2 to 3 times better to do that versus, is it just that the coal that you're using to reduce iron in general is like releasing that much more CO2 into the atmosphere? What's the...
Right, it's exactly that. I think Shaun mentioned it. Like you have the avoidance, like the reduction in emissions and the carbon removal, because you'll get the metallic iron and then you'll be able to put the CO2 underground. So in terms of like total carbon removed, it's like 2 to 3x by going through that steelmaking process.
Yes, everyone.
Hi. So I just looked at your website as well. One of the values which you have is do no harm, right? And that kind of resonates with even archaeology also, like if you're doing any excavation or anything with the earth. Mm-hmm. So what keeps you at night of like, how possibly this could go wrong? Today I'm doing this in the hope of reduction of carbon, but are there second, third order, fourth order effects which I'm not seeing, which keeps you awake?
Yeah, I mean, there's always risk in programs. I think like in do no harm, what you want to do is, where our approach to do no harm is making sure that we are, I think the best way to describe this is I used to work at a research station, and there was a safety slogan contest, and the one that won was nobody move, nobody gets hurt, right? And this idea is, as an engineer, you want to balance risk with with safety. And so you do like a failure effects modes analysis on everything. And you want to look through and make sure that every failure mode, you have a, basically what is the likelihood of that impact, and then what is the sort of the risk to any system through that impact. And if either of those are like above a threshold that you've determined to be safe, like you can't operate in that regime. And so I think the biggest concerns that we have are making sure that the wells that we've selected don't have risks to groundwater resources, and that's what's protected through the EPA's Underground Injection Control Program, is all about protecting groundwater resources. And so I think the risks that we have are around how do we ensure that people operating near the equipment are safe. And so we definitely go overboard, I think, as an organization to make sure that our team isn't exposed to anything dangerous and that we're wearing the proper protective equipment when working with hazardous materials. And I think that the long-term tail of the process that we're working on is making sure that if we're removing biomass from the field, we're not contributing to soil erosion, or to, if we're working on forest thinning, that we're working with organizations that are doing it appropriately and not creating like these second and third order knock-on effects. So I think it's just like we have to look at every component of our process and give it the same like risk analysis that we give to any engineering process that we're working with. So.
Yeah. Ben, and just 1 second, let us get the mic to people on the streamer.
Hi everyone, I'm Finn. I feel like in Silicon Valley, there's this bias against hardware startups from like a lot of funders and people who are going to be potential hires as well. And one of the interesting things about the New American Frontier series is we've had folks from satellite companies. The founder of Anduril came in the other day, and these are like some companies that have kind of like reframed that perception, I think, very powerfully in the last few years. I guess I'm curious, like my question is, how have you guys approached that when talking to funders and to potential hires, and kind of told the story of like, hey, we can achieve a really big outcome here. We can scale very rapidly despite being maybe a more hardware heavy type company.
Do you want to take it, or I can?
I can take the initial one. I think generally, yeah, in the maybe Silicon Valley generally, you've seen a lot of consumer products, right? Where it can help you with this fitness thing or some sort of like home tech, et cetera. And
Juice production.
Yeah, and like they're not necessarily like major like global impact type of work. So I think the climate mission and intent is really strong. I think climate tech is generally an attractive industry for fundraising right now. Like the climate problem requires it. So it's hard to argue against doing that type of work right now, and putting even though that there's risk there, putting a lot of eggs in that basket because we require it as a global society. Other than that, I think it's about being smart in the implementation and thinking about if there are creative ways to think about project finance or other financial instruments that maybe looking at ones that haven't worked in the past, if solar like is one example perhaps, and then figuring out if there's unique ways to change those to be more favorable to some of these high risk endeavors in order to, I guess, push the envelope on what's possible. But
yeah, I would add to the like VC side of it. There's two aspects of that. One is that if you're building a hardware company, you want to make sure that you're working with VCs that understand the complexities of a hardware company. One is that it's way more expensive. The other is it's going to take a lot longer than even our ambitious yet hedged projections. So I think that's one aspect of it. The other is carbon removal. Charm is the largest permanent carbon removal company. We're about 10 times the size of direct air capture. And we've done 5,000 tons, which as a frame of reference is about 4.5 Americans' lifetime emissions. And we are the largest in the space. So the scale of the industry needs to grow at over 65% year over year for the next until 2050 to be able to hit 10 gigatons. So from a VC's perspective, like they're not necessarily coming at this altruistically. The entire industry has to grow at more than 2 times the rate that software grew over the last 20 years. So there is potential for a massive upside if the organizations work, which is kind of why you see a lot of like investment in the space, but it's also like reckless investment. We know of some organizations that are raising money, and we hear that they raised like an enormous number, and it's staggering because like we are definitely working very hard at building a prototype. And if anyone's thinking about building a hardware company, please build a prototype. That is the most important thing you can do. We talk in the space industry about like paper satellites, like groups that just design a satellite on paper and then they go try to raise money. Building a prototype, testing it, learning from it, showing what you don't know is the most valuable part of building a hardware company. And so doing that, getting it to a prototype, then getting it to a space where you can use these financial instruments that are outside of the venture capital model are critical in scaling.
Yeah, and I think that's where our other co-founder, Peter, really like shines, right? He knows how to fundraise for a company, he knows how to do a lot of company building. And so we partner with him as hardware engineers in order to kind of tell the story that we need to investors and really make them understand kind of, yeah, those big levers that say like, this has to grow, like the world depends on it. So like we should get started and here's like all of these risks, but here's how we're going to address them and just kind of laying those things out.
Mm-hmm.
I'm curious to address like the has to grow thesis, just because I think that might be like a scientific consensus, but making that an economic or a market consensus is really different.
Mm-hmm.
And there's sort of a dependence on legal markets for carbon as a thing, which, you know, there's not really global markets for that. I think, what was it, the Kyoto Protocol kind of wiped those out, or the United States withdrawing from it. So kind of curious how you address the fact that this is really dependent on a state-by-state solution, or do you have hopes for other solutions?
Yeah, I think when I say it has to grow, it's definitely under the like auspice of like I want to stay on this planet. Ideally, every year that goes by, it's going to get harder. So we talk a lot about like tipping points, and you know, the permafrost methane is just wild. So the methane is a whole other animal that we can get into at some point. But I think just from a carbon dioxide perspective, when I say it has to grow at that rate, it's based on the IPCC reports saying that we need that on top of all of the reductions. And so if we don't get to the reductions targets that exist now, then that number actually grows over time. And so I think there is a role for government to play in this. I mean, you can think about how nation states have been profiting off of extraction for the last 200 years. And so like there's an aspect of that comes home to roost in the need to be impactful in climate. And we are seeing a massive swing in the last 20 years on the realization that we need to do something. And so I am hopeful that government will step up and act, but in the interim, we are working to develop a solution that's scalable so that when calmer heads prevail, there is something that physically exists, or we at least have a 10-year head start. So, yeah.
I don't know if there's an improved methodology for your work already, or I assume also it sounds like going into the compliance markets, that's probably down the road. So yeah, would love to hear about that.
We actually just announced an MRV, we call our proto protocol. We worked with eco engineers and Carbon Direct. Am I getting this right? Carbon 180.
I'm sorry.
Carbon Direct.
Carbon Direct. Thank you. Okay, thank you. Sorry, these regulatory and science bodies, like they all have carbon something names, and it's really hard to get them all straight sometimes. But anyway, we were working with them. Basically, said, hey, we want to develop this MRV protocol. What would you like? Here is generally how our process works. What would you recommend? And so they kind of stepped through it and figured out those points that you can actually put a meter on something and say, this is how much carbon is emitted, or this is generally the emissions of each step in this process. And right now we're developing an even longer protocol based on the proto protocol we announced. So I think we have a blog post about it on our website and the protocol, so you can read about it. But basically it's looking at everything from we've taken this biomass off the field, what is the emissions of our process, what are the emissions through all of the sequestration and transport and so on. And where can we, how often do we have to monitor it, and what are we're kind of developing the error bars on those measurements.
And then I think on our registry too, we have a public registry of every kilogram of carbon we've put underground. And then if you go through our website to the registry, you can actually see the life cycle assessment of every delivery. And so if some deliveries are captured within a single process, there's just the one result. But if it happened over, let's say 3 different injections over 3 different points of time from different bio-oil sources, they have those each associated carbon removal aspect there. But yeah, we publish our proto protocol with the intent of getting feedback on it as well. So.
Yeah, so to that point, in the carbon credit and carbon offset markets, we've seen kind of a race to the bottom in that a lot of companies just want to buy the cheapest solution. But when you dig under the hood and apply some scientific rigor, you find that the claims that they make don't actually hold a lot of water. In the companies that you've worked with, have you found that they are valuing these credits differently, in that they are taking a much closer look in the impact that a project will have versus just the dollar per ton?
Yeah, for sure. We're in a really interesting time in the carbon removal space, where for each one of these RFPs that go out, there is a lot of work that happens on the backside. There's the public sort of document that Charm submits, usually public, it's private in some instances, but to talk about what we're doing, where we're operating. And then groups like Microsoft and Stripe and Shopify each also came forward with a scientific review board. And so they brought in experts from universities all over the world to sit down and talk through our process, to review our approach, and then talk through what we're doing to measure each of these things. And so the way that Charm operates right now is outside of one of these regulated, not regulated, but one of the spaces that is trying to sell gold standard market products. And that's because they need to verify 100% of your removals, and they charge a fee on top of that that's ostensibly passed on to the end user. And so what we're trying to do is say hey, we can get an additional removal within our product, and here's every way that we're measuring this. And so by being transparent with our process, we're trying to remove more carbon in the through that process. And so these early customers have been very tech savvy for the most part, and so they are willing to work through us and understand that our process has the benefit of being able to have a scale on the input and the output, and we can measure every atom of carbon that's going underground, and that's what we sell. So that's kind of Charm's differentiation in the market.
Do you see that applied to the market more broadly? Because obviously there's this consortium of tech, very science focused, but there's a much larger market. Do you see that filtering down, or we're not there yet?
Yeah, it's difficult because every technology that comes on has a map of how measurable it is. And so there are people who are working on things like enhanced weathering, and that is a very difficult to measure process because it happens on long timelines. You look at anything working with the ocean is extremely difficult for not just measuring the carbon removal, because some of these things happen over 1,000-year timelines. And so how do you measure that? How do you sell a product that has an impact over that kind of timeline? And so there are incredible people working on each subset of these problems. I think that there will be a different solution space within each of those challenges. And so our space, the benefit that we have is everything is extremely measurable through our process. But other groups where they're putting, say basalt on farmland, they have a different set of measurement challenges. And so I think that the industry can benefit from people who are diving deep on each of the subsystems and creating either a transparent way of measuring it, like Charm is trying to do, or creating a methodology that's accepted across a larger organization. And so to get into the regulated market as well, we need to have that process approved through those regulatory pathways. And that's what we're working on right now as well.
And I think you're seeing the portfolio approach a little bit more than they used to. Like it used to just be like, oh, I just want to buy this tonnage. And but now you're starting to see, okay, we want to buy this tonnage, but we can reserve some amount of it at this price and some amount of it at that price. I'm hopeful that it continues to go that way. And then also when it comes to delivery, like at some point, we'll have to say like, okay, are we actually delivering carbon removal? And so we're hopeful that we can actually deliver carbon removal when they start saying those things, versus some of these places where they're still ramping up or it'll take them years to ramp up. And when can we really start to see the effects of that?
So we have plenty of questions left. We have no time left. We're not giving. Maybe can we do one more question or? Yeah. I believe you raised your hand earlier, right?
I mean, it's my question. First of all, thank you so much for coming in today. It's a really fascinating talk. I think maybe it's more of a follow-up from the last question, which is, I think you mentioned in 2020 when you had that breakthrough moment, very quickly you signed Stripe as a customer, which is obviously like a huge logo customer. So I wondered if you could go into more details on like the specifics of that proposal that you brought. Were they actively running an RFP? What were they looking for? Also, like, who are the decision makers at these companies when you come to them with a proposal like this? And then maybe part two of that question is, you mentioned Shopify and Microsoft were next, and that's just like a really impressive streak. So I'm wondering if you can talk more about kind of learnings from deal to deal and like what you've biggest takeaways from a go-to-market perspective.
Yeah, I think our first approach, so Shopify was running an RFP. They said, we want permanent carbon removals, like, what has the world got? And at the time we were working on the biomass or bio-oil to hydrogen process, we had already split the process. And so we're like, well, we could do carbon dioxide sequestration concurrent with our hydrogen plant that we're designing. And we got basically a bounce back from Stripe being like, that's not really what we're looking for. And while I was trying to figure out when lockdown happened, and we were right around the time of the Stripe RFP coming to an end, we had the realization, or had the breakthrough that the carbon-containing oil could be injected. We sort of sent a response back to that bounce back we received, being like, would this shape of thing be interesting? And they said yes, and so we went from so we put together an RFP, which is public, and we sent that out, and it was accepted. And then we continued to, basically in the due diligence of putting that RFP together, we had to create a process that could close, and we had to set a price point. We had to understand like everything. And so in the span of like 2 weeks, we went from concept to a fully formed RFP that was something we could stand behind. And then we had delivery within a year. And so it was a violent ramp rate, but that ramp rate forced us to solve all the problems we would need for delivery. And so then when the next RFP came along, we said, yes, here's our portfolio. Here's the project that we're running. And so the benefit of our process was it was novel, and there was like measurable aspects of it. And we were able to spool up existing resources to deliver it immediately. And so that was also something that was interesting to Microsoft when they ran their RFP, as well as Shopify. And the people who are behind the scenes, as far as the decision makers, are incredible people. They're in these organizations trying to create impact in the carbon removal space. And so I think it's a little bit different than another standard sales model, because your customer, you're meeting with them on a monthly cadence talking about deliveries and where you are in your research and development process. And most customers, I think, if you are slipping a delivery or you are like, something is going wrong, they can be like a little contentious about like, hey, where's our data? Where's our solution? Where is this? Whereas in the carbon removal space, they're saying, how can we help? What is something that you need to help this move along? Because they are interested in getting carbon underground versus and being catalytic in the industry. So it's a wonderful customer model. I don't think it's directly mappable to a lot of other spaces, but I think just, yeah, building something you want to build, and like if you have your heart behind it, it's pretty empowering to get other people on board, I think.
Yeah, I'm trying to think if there's any lessons learned from deal to deal. I think that all three of those processes are very similar. As Shaun mentioned, like in their kind of interactions, I think the due diligence was slightly different. I think Microsoft, for example, was a little bit stricter on like, okay, well, how exactly are you going to do this? Whereas Stripe really wanted to be like, here, go develop it.
Mm-hmm.
So I think the processes were just different in length, different in their like scientific teams behind it. Those scientific teams had different areas of expertise. So one person might know a lot about biomass, or another person might know a lot about sequestration wells. So that was really interesting as we went through it. And then, yeah, I think just being as transparent as possible and trying to balance that ambition with reality, and especially for customers who want to see that delivery happen, versus customers who are willing to be like, whenever, like we just want you to keep moving forward and we want to see progress.
And I would say one other thing with that too is we were adamant to admit where the edges of our understanding were and bring in experts. And so a lot of that time during that RFP process was having people who are injection well experts write memorandums of like, this process is sound, here's the research, we stand behind this, and then going through that in each part of the process that we had that we were unsure about. When we were building our early chemical plants, we brought through experts, especially, this is back to the do no harm, is we understood the bounding boxes of our experience with safety. And so we were like, okay, what are we missing in this analysis process? And so when we were in those development phases, we had experts fly in, go through our plant with us before we turned anything on to make sure that we were not missing an edge case that was potentially dangerous. And I think we are trying to do the same thing with our underground injection program and our carbon removal process, is make sure that there's not an edge case that we're missing. And so I think be eager. One of our other values at Charm is to, like, you are not alone in the space, and so you want to look outside of yourself, look outside of your organization. I think places like South Park Commons are great at that, where you're bringing people together. There's always someone in the room who is smarter than you in an aspect of what you're working on. And if not, like, you should be finding those people. So.
Shaun, thank you so much for your time, your patience answering all the questions, and for all the work you're doing. Round of applause. Thank you.